something that you don't have a really strong advantage in if you don't have to. I mean, that's how I would make the decision. I like wait till somebody shows up with something that's better than what I can do. So I understand the whole copper thing. Like you just, the inertia of a large company who develops technology is typically not to obsolete themselves. It's very rare that that happens. So I don't ever see them doing that. And certainly someone who's a consumer of technology at a very large scale, certainly copper has all the advantages today in supply chain and deployment, pluggables and all that. Just from our perspective, when we look at co-package, it's really the density question. How can we get higher amounts of density of ports? The reason why I think if the data center transitions to a fully disaggregated all photonic architecture, you're just going to need a large amount of ports, a large amount of fiber. So anything that helps reduce those things is really where the magic's going to be. You can start to do it today. It may not be the most efficient design, but so many of the things that you heard the prior presentations about more wavelengths, higher density, co-package, all those things in time will weigh on the supply chain. That's definitely my bet, right? So and I'll go out and sell that message. That's what I'm going to do. But today, if you were to ask me to build, 20,000 GPUs, these guys just announced, a couple designs in those scales. I mean, it'd be very hard to do it all optically.
Go ahead.
So, when we first really started talking about co-packaged optics as an industry, it was all focused on switch bandwidth. And so the comparison for co-packaged optics wasn't copper cabling in a backplane, it was pluggable optics. And I think you can still do the math now and see integrated optics versus pluggable optics, there's a clear advantage. It comes at a different risk profile, it comes at a different sort of serviceability profile, and all those things matter, especially when you do it at scale. When we talk about AI ML, though, much of the bandwidth is really, we're being discussed, right, is the endpoint, right? And the endpoint, as Vlad pointed out, is sort of meter, 1.5 meters. So now the competition isn't pluggable optics because we're still not using it there. It's what's a copper backplane. It's not even a DAC cable, which is costly compared to a copper backplane.
Yes.
I mean, I think Ashkan did a good job at the Optica Summit at OFC, sort of putting up a chart, sort of comparing. If you look at the cost of bandwidth between an ASIC and an HBM, you're talking about on-package copper traces, which are fractions of a penny. If you're talking about the bandwidth between a GPU and its nearest neighbor, CPU or GPU on a board or cables in the backplane, it's still fractions of a penny. Where is co-packaged optics compared to that? Or power, right? I mean, we're ladling optics power on top of electrical power at that point. So what is the advantage? And I think someone told me this many, many years ago, right? If all you do is plumbing, then all you'll be paid is plumber's wages. So if we're having conversations around copper cost and copper power versus optical cost and optical power, the road is steep. So what's the killer advantage? What does optics bring to this that copper cannot bring to this? And what I think Bill hit it on the head, right? Shoreline bandwidth density, bandwidth density over distance is sort of the killer optical thing. When those things become prevalent and required, that's when risks and innovation will happen, I think.
Yeah, I would just echo that. We see an end to pluggables in the next decade or so. You're already seeing linear drive take over from transceivers or start to take over in certain applications. I think co-package optics, near-package optics certainly have a future. But what the OCP has recognized is that the solutions are all over the map. If you were attending the Future Technology Symposium in the fall, there was many companies, many vendors offering multiple different solutions. So what the OCP has done is established a work stream. It's a short-reach optical interconnect. And just a plug for that work stream, I happen to be chairing it, but please come with your ideas. What we plan to do is define how optics can provide that advantage. Drew mentioned it, it's shoreline bandwidth density, power, and we're not going to maybe define form factors, but we're going to define how, what's the OCP's recommendation for vendors. If you want to come and play in this new world where optics, get closer and closer to the silicon, how can they be effective? There's no reason to drive an electrical trace across a PCB. if you can go to optics immediately. I mean, furthermore, the bandwidth that you can provide in multi-wavelengths in a single fiber, is an order of magnitude better than what you can do in a copper interconnect. So that's where we see the future. We don't have the answers yet. That's what the work stream's about. But trying to sort of pave the way for predicting where the solutions need to be developed for the future.
Okay, 2 quick questions, please, and then I want to open it up to the audience. Do you have any advice to all these different photonics players coming at this from different directions, whether it's comb lasers, co-package optics, LPO? There's a whole variety of technologies, optical interposers. Is there anything that you see that's missing, that besides, say, lower power or more cost-effective? What guidance would you give them, or is there anything that you're looking for that you're not seeing?
Well, I suppose I would answer that as I said in the talk, the development cycle for integrated optics is long. Decisions have to be made earlier on in the design cycle than we might otherwise be happy with. And so, first demonstrations in the lab are necessary but not sufficient conditions for us to make product decisions on. We need maturity of the optical end-to-end link. There can't be a flow chart with a little cloud in the middle that says miracle happens here, right? I mean, if we need to turn on a 24,000 unit cluster or some X number of that, and we need all of that to hit in 3 months, it can't be, trust me, I'll figure out how to partner with somebody and make it happen. That doesn't work. And so maturity earlier in the process, shooting way ahead of the duck is an important part, I think, of scaling to the volumes needed for these very large clusters.
So as a company that I'm trying to sell to end users, so we're out doing designs. I was doing designs a few days ago on like 5 sites with like 64 GPUs there. It was all kind of Gen 5 stuff, so it's very small scale, but in a tight configuration. So I will tell you what we need is better pricing, like just shockingly. I mean, but part of that is just the maturity of the supply chain, people getting larger orders through. That will happen in time, but I can't order in this case, we do have a co-packaged optics product coming, and I was doing a design and a quote. I can't be designing and quoting at the kind of like initial sample build price. It's got to be on par or better than pluggables, because that's the model. So I'm going to need to get to pluggable laser prices, and I can tell you I can buy a 100 gig pluggable for $170, and I'm sure he can buy it at a way better price than that. So that's where just the market's going to have to go to do practical designs in the field. But that will come over time. Every year they'll be a little bit better. And by the way, the copper guys, and I'm sure most people have heard Andy talk about this, the copper guys will continue to innovate and try to get copper cheaper, and that will play. But at some point, the reconfigurability and playing with all the ability to stitch and manipulate bandwidth and have better use of fiber, that will all come into play and it'll be an advantage. That's at least the bet that we've made.
Okay, last question to all of you, very briefly. You pointed out earlier the danger of even looking a year or 2 ahead, but if I can push you, what do you expect to see in 5 years' time?
Wow, okay. I'm still shocked at what happens in a year. I don't know if I can answer that question, but I know what I think we'll need if our approach to the architecture design is, and that's a much larger switch technology. So that means I'll have to eat the message that I just said, which is we'll have to build an all-optical switch that has a lot of ports and drives at a very low price point. And that's just going to take a few years to get there. Someone else wants to attempt the question.
I don't want to touch it. I mean, linear curves don't seem to work in this realm. But I mean, if you talk about a linear curve, 5 years, right? We were at 16,000 nodes last year and 24,000 nodes this year, so it's 50% year over year. We're at how many nodes, right? How much distance is that? How much power is that? I mean, and to be honest with you, I know the linear curve isn't accurate, so we need more, and it has to be more bandwidth at the lowest possible price and power points to deliver what it is that I think we want and need. I mean, develop responsibly, right? In there's a lot of innovation there. It's more.
I think, so in 5 years' time, what you're gonna see is an all optical fabric within the data center. I think that's a fairly good prediction. There'll still be legacy implementations, but I think by and large, your data center will have an all optical fabric. So there'll still be, copper largely within the rack, but I think that profile is going to move towards optics closer to the processor, the GPU, the memory, put it that way. So optical memory interfaces, optical GPU, CPU interfaces, so that there will still be pluggables, but they'll just be direct attach. The optics will originate right next to the processor.
So I think, on the subject of the cost of optics, it's only a question of volumes. If we double the volumes, the price can go down quite quickly. And we've seen examples of optical technology scaling in cost to surprising numbers. Like when Apple started putting in VCSEL arrays in their face recognition systems, the cost of a laser, the cost of a laser array with 300 lasers was $1.50. I can't even convert, counted per laser, it's like a fraction of a penny. So suppliers can scale the cost down given very high volumes. And we've seen technologies like what Richard was showing. It's an amazing technology. There's so much engineering going on into those hard drives. But once you make them in hundreds of millions, they don't cost as much as you would think. So I think we will be surprised 5 years from now how the cost is going to come down. And I think I agree that there are a lot of benefits of having an optical fabric, which adds additional value to the optical connectivity. You cannot do an optical switch with copper cable. So I think that those trends will probably converge and kind of work together for the benefit of our industry.
Thank you. Okay, let's just have 5 minutes of questions. Anyone would like to ask? Here we go.
Well, that's a hard question. I know.
No, it's not for you. I have a previous one first. I have 2 questions. The question is, a lot of companies today come with gorgeous idea, in terms of how to solve this density, how to reduce cost, how to reduce power consumption. And sure, we come from a long time with 3.5 technology when it's a mature technology. I would say everybody knows what can come, reliability and everything. And when we speak about peak technology, major companies who are developing are fabless. Okay, they are totally dependent of outside foundry. Each foundry has its own cooking, how to make it. Then my word is coming to Andrew was saying, where are we with the maturity, the reliability of the product today? Because following where you go from a foundry to another foundry, you don't get the same product, you don't get the same maturity on the product. And as we know, in the world we are developing today, it's very important to guarantee the services, Then question here, how could you guarantee that what today you are pushing with the peak technology, you will get the right maturity to be deployed next year or in 2 years?
Well, as somebody who wants to consume all these technologies, I would agree with you that there's almost every vendor who's come and pitched us, tried to get us to design in some sort of optical technology. About 18 months ago, they said it would be available in 6 months, and we still don't have some of it. So it's been like I would almost say literally push all the vendors who've come and said, hey, design our part into your solution. It's been about a 12-month push. So just a slow process, getting maturity, getting yields, fixing, running another. Yes, I think that will solve itself over time, but it's clearly an issue. I wouldn't lie about it, right?
So Vlad showed a very interesting chart early on, silicon photonics volumes, right? And when I was involved in the early days of silicon photonics pushing that, we all thought it would be faster as well. It is just a long, slow, steady slog to collect the data, to sort of build it up, to build the manufacturing know-how, and to ensure that you can consistently deliver the right product at the right price point with the right yield over time. is that sort of innovator's dilemma in some sense, right? Let's be really, really creative, but it has to be mature, and how do you get there, right? I mean, it's unfortunately a reality, I think.
Any other questions?
Okay, then when you start this morning the pitch, then I have a good question for you. You know, you said it would be no for the panel. OFC was one month ago, okay, and it was clear from the major company as Meta or Google or Microsoft or Amazon that, you know, 2 years ago it was non-C, then non-China, and then we were there, it was non-C, non-T, non-China, non-Taiwan, you know. Then my question is now how to handle this situation in terms of the supply chain, because today majority of the supply chain is coming from Asia and mainly from China. And I know that there are a few companies bringing back production in the United States, but how do you see this transition? First, in terms of the capacity, and number two, in terms of the cost for the optics, because I assume the optics manufactured in US will be more expensive than the solution manufactured in China.
Well, we certainly see a disconnect between the politics and the trade. You know, if you look at the statistics, trade between US and China keeps on making new records. So the businesses find ways to work around the barriers if there is an incentive for it. So no matter how hard the politicians work, businesses still find ways of doing it. Having said that, all the leading Chinese suppliers of transceivers that we work with now have factories either in Thailand, Vietnam, Malaysia, somewhere else. So they're not totally dependent on being in China. I haven't seen anybody transferring transceiver assembly and testing to the US yet. I know some companies have factories in Mexico, and but
Vietnam.
say it again.
Yeah, number of the suppliers that we talk to, they all are moving to Vietnam. Or
Vietnam.
they'll have something
Correct.
to do with
Correct.
Yeah.
So it's just going to move to other countries in Asia, I think, to mitigate some of these concerns. But I think I'm optimistic that businesses will continue to find ways around the barriers that politicians are building.
Okay. I'd like to thank the panelists for sharing what they did. And now Vlad's just going to finish up.
Well, this is the first regional OCP summit that I'm attending, and it's the first time the regional summit has a session on optics. We've been doing it as a global summit for probably 2-3 years now, and of course it's in San Jose, which is a mecca for the optical startups, but it's great to see European startups coming to this event and sharing their ideas. And speaking of ideas, you know, I was listening to Josef's presentation. I think he has enough ideas for like a dozen of startups, which is often a challenge. I mean, it's part of it is a criticism too, because running a startup, you do have to focus. You know, you have one chance to succeed, so you put all your efforts into the most likely success story. And as a professor, I understand you try to show that you're a magician, you can do everything, which is fantastic for me as a former scientist to see. But, you know, bringing technologies to the market is not a sprint, it's a marathon. And you need to know the direction you're running. You don't want to turn around and you're going to run out of energy pretty quickly. So I think, you know, my recommendation to companies, whether it's New Photonics or Enlitra or other presenters, is having more focus and putting your bets on what's the most promising, what the largest opportunities are, taking risks, because you startups, it's okay to fail. You know, you'll start over again. My very good friend is one of the co-founders of InnoLight. And InnoLight is, for last year, they're going to be officially #1 transceiver supplier. So for the first time, they're shipping more than Finisar, which is now part of Coherent. But this friend of mine was telling me a story that InnoLight was his third startup. And when he was raising money, he talked to a technical team saying, "Are we going to screw it up again, guys?" And they're saying, "Don't worry. By now, we made all the mistakes we could have possibly made. So this time it's going to work." And yes, you know, it was the third time around, and it did work. So don't be afraid to take a risk. I mean, that's what it takes. If you play it safe, you're not going to succeed. If you try to solve all the problems, Josef, I mean, you're going to be great. As an intellectual achievement, it's fantastic. As a business story, you've got to focus on something that you could deliver soon and make money. Go ahead, yes.
May I answer it?
Yes.
Okay. At the end of Q4, we will have engineering samples ready with monolithic integration of lasers, modulators, receivers, equalizers. So we are focused on the products. Today, my goal was to present the major
I
goals
understand,
of things,
yes.
but we are very focused on the production. So
Right.
we will very soon provide the engineer samples.
Right. And Josef, I didn't mean to criticize you that much.
I definitely agree with you.
Right. And, you know, just one last thought. I really like the message that Drew pointed out. Don't shoot behind the duck. Even if you're developing products like for 200 gig per lane, so Yannick, you were talking about 8 times 200 gig per lane. You know, companies are being qualified now. They started probably 6 months ago in qualification process. So if you're a startup, yes, you're developing 8 times 200 gig per lane products. It's your learning exercise. What you're really going to be selling is the next generation, whatever it's going to be, 16 200 gig or 8 by 400 gig. So you kind of have to shoot well ahead of the duck because it's a 5-year span that you're trying to cover. So it's an interesting, it's a complex world, but it's incredibly interesting. So I wish all of you success. We're here to help as Light Counting. We are, you know, bringing clarity to the market, and we're helping all of you to succeed. So we are on your side, including Josef.